So here's your homework assignment. We're not going to rush through this right now. So what I would like you to do is do these two examples. For this first example here, we have a certain water level. Okay? So pretend water's going over the roadway, whichever direction. Maybe it makes more sense if you pretend it's going over that direction. H, or the head on this broad-crusted weir, because this is a road, so the broad-crusted weir is 2 feet. So that means our coefficient of discharge is around 3-ish. The length of the weir, yeah, Veronica?
The only thing you didn't tell them is where to get that H for weir. You didn't mention where you get it.
Yeah, so, oh, that's a good point. So this H, could flip all the way back. It's not too bad. So you see this H is measured, and again, it's a water. We're assuming the water surface, although it's really the energy grade line, to the crest of the weir before it starts to neck down over the weir. You see where it starts to dive down through here? If this is not submerged, it's going to dive down through critical depth and then continue over the side. So before it starts to dive down over the top of this weir, that's where we want to take it. Before that water surface begins to contract vertically and go down. So we measure it someplace upstream before it starts to dive down. Thank you. All right. So we have the H, coefficient of discharge, we're going to assume is around 3. The length of the weir, and again, that's perpendicular to the flow direction, because that's like this. For this case of this example, assume 100 feet. Assume that the total flow coming down towards this culvert is 1,200 cubic feet per second. And your job is to find the flow through the culvert. Okay, so think about that. And you also have a couple minutes to ponder this in the morning, and then we'll talk about it. See if we all are okie dokie with what we're talking about. Next problem, given this riser here, and we're going to assume, I think there's probably 3, I'm guessing there's 3 or 5 here, I don't know for sure. Let's assume this riser with 3 orifices, and they're all at the same elevation. And so the H then is measured from the water surface to the center of area of this orifice. Is 12 inches or 1 foot. The diameter is 4 inches. And let's assume the coefficient of discharge for the all 3 orifices is 0.61. Pretty straightforward. We want to find how much flow we have going out of our detention basin. So ponder those 2 things, and we will discuss them first thing in the morning. Could I have a time check, please? What time is it exactly? 3:58. So I'm giving you back 2 minutes out of your day. You can thank me after the fact or tomorrow or whatever, but I'm giving you 2 minutes back. All right? So we'll start off talking about this stuff. We start at 8 o'clock promptly, is that correct? And then after we do this, then we get into the really good stuff, culvert design. All right, so let's move on. So I mentioned probably at least twice yesterday that, and I'm not exaggerating, I am kind of a lazy person at heart. I'm forced to work hard a lot of times to get the paycheck so I can put fancy feast in the cat food. However, at heart, I'm kind of lazy. So, do we have a volunteer to come up and talk about the solution to our first problem? Someone feel confident in the answer that they got, and they want the respect and esteem of their peers. Nick, would you care to?
Yeah.
All right, so we need a full description of the solution and how you came up with it.
So we're given the waterhead, we're given the coefficient of the weir, we're given the length of the weir, and we're given the total flow over this entire thing. And we want to find out specifically the flow through the culvert, which is not what we're given, but instead what we are given, you basically just plug the numbers into the Weir equation right here. So you get the 3.0 here, 100 feet here, and 2 feet to the 3/2 power. And that gives you roughly 848.5 cubic feet per second. But then what you do is, that's going over the road top. That's the water going over the roadway that's acting as weir. And so we subtract 1,200 cubic feet per second, subtract 848.5 cubic feet per second from that. That gives us 351.5 cubic feet per second flowing through the culvert.
Everybody get that? Are there any questions? Okay. And so which of our three fundamental equations did we actually kind of use to come up with the solution? Conservation of mass, right? So we have a Q total of 1,200. So the flow that's not going over the top of the road has to be going through the culvert, right? In this particular situation, assuming it's not going over a sag point somewhere else or through another culvert or whatever. Excellent, thank you, Nick.
So theoretically, you could have done this problem, or it could have been set up the other way where you knew the flow through the culvert and not something else, like not maybe the hydro or the road or something.
And I didn't do that specifically because we're going to be talking about how to calculate flow through the culvert. That's exactly true.
Okay.
All right, the second one, and we have another different volunteer to talk about the solution to this one. All right, perfect.
So we have the 3 orifices, and we're given a diameter of each one of them. So you first figure out the area of all the orifices.
See, it is hard to say, right? Right?
Of all the holes. And so you figure out the area of that, and you convert it to feet, because it would make sense for it to be your feet in this equation. So then you use this equation with your CD, 8.61, and then the area that you get from all 3 of the holes. And then you do your gravity and plug it in with 1 foot as your HD. And then you should get 1.28.
1.28 CFS. Does that sound okay? Getting a lot of nods. So, Katie, thank you very much. Keys here are always be careful with your units. Make sure you're using the appropriate units in the equation. And then the coefficient of discharge, I don't know if these are in your EPG or not. Use whatever is in your EPG, and if they're not there, then you can look them up using a valid reference document of some kind. I'm trying to think where we would have them in our stuff. Because I actually went looking for them. I think a couple of them are given in HDS4. But if you ever have questions on where to track them down, just shoot me an email and I'll help you out. They're kind of more in your standard hydraulics texts from college and other things. All right, excellent, thank you. And just another plug for the hydraulic toolbox. Actually, the Weir and Orfice equations are pretty straightforward, so I wouldn't say you need to go into the hydraulic toolbox. There is a Weir calculator in there. The Weir analysis, this one right up here, excuse me. The Orfice equation is actually built into the detention basin one. I think it's this one here. The detention basin calculator. And so if you go in there, then you have to actually put in your stage storage and stage discharge curves for your detention structure. And then you go in and identify the outlet structures. And you can use riser pipes and other types of structures for your outlet. So it will help you do some very basic detention basin analyses. I think you most likely have software that you use in-house that it's probably a bit more sophisticated for stormwater management design. I'm guessing. I think most states have, so it's probably one of your Bentley or whatever products. All right. So back to our learning outcomes. We just talked about weirs and orifices. We described structures that are analyzed using the Weir and Orfice equations, and we actually did some application of the Weir and Orfice equations too. And we will continue to do that because culverts and inlet control condition use the Weir and Orfice equations for the analysis.